For problem number 71 on page 23 in chapter 1, we're looking at solubility curves. So first of all, in this solubility curve, to determine whether it's saturated, unsaturated, or supersaturated, if the point is above the line, that means it's supersaturated because there's too much of the solute to be dissolved in 100 grams of water. If it's saturated, that means it's right on the curve, which means that there's the perfect amount for the 100 grams of water, which is the constant. If it's under the line, that means it's unsaturated because there's not enough of the solute to be dissolved completely. I mean, it will be dissolved completely, but it'll be not the perfect amount as the curve represents. So for A, at point A, which is right here, how many grams of the compound are dissolved in 100 grams of water? Is it saturated, unsaturated, or supersaturated? So for A, approximately 120 grams of the compound will be needed to dissolve in 100 grams of water in this situation. That means that it is supersaturated because the point is above the curve. That means there's more solute than 100 grams of water can hold. At point B, how many grams of the compound are dissolved in 100 grams of water? Is it supersaturated, saturated, or unsaturated? So that would be about 40 grams of the compound, as shown right here. It is unsaturated because it is below the solubility curve. So for C, how would you prepare a saturated solution at 30 degrees Celsius? So 30 grams of the compound should be dissolved in 100 grams or 100 milliliters of H2O. Because if you look at the graph here, the two axes are temperature for the x-axis and mass of the solute for 100 grams of H2O on the y-axis. So that's why we've been talking about how much of the solute should be dissolved in the water, because that's the y-axis. So for temperature, for this C, you would look at the x-axis at around 30, because you want to see if it's saturated. That means it would be on the line. So when 30 is the x-axis, that means the line is right about 30 grams. So if you draw a line to the mass, it would be about 30 grams. So to actually make the solution, you would measure 30.0 grams on a mass, on a scale, using a plastic weighing tray. And then you would mix it with 100 milliliters of water measured in a graduated cylinder. This makes it more precise. When I said that there should be 100 milliliters of water, I said that because density is equal to mass over volume, and water's density is defined as 1 gram per 1 milliliter. So that means that 1 gram of water is equal to 1 milliliter of water. Therefore, when you want to dissolve it in 100 grams of water, it's the same thing as 100 milliliters of water, which is way easier to measure in a graduated cylinder rather than on a scale. When you stir that in a beaker with a stirring rod, that's the solute plus the H2O, it will hopefully dissolve perfectly and have no precipitate because it's a perfectly saturated solution.